For this lab, we're going to study the wave functions from the hydrogen atom. There are lab instructions here, some example work from previous years you can take a look at, see what the goal is. There are individual tutorials that you want to check out, especially this pitfalls tutorial. It shows you some of the things that can go wrong. If we look at the handout, what we're doing is we're trying to visualize a three-dimensional function here. R, theta, and phi are the three parts. I give you explicitly all the formulas that you need. We're going to be combining these three things together into one overall wave function and viewing it using the volumetric software Slicer. Think about what you're doing. Here's a plot of the angular parts for the different orbitals, and down below here you see the radial parts. What you're doing is combining these two graphs together and visualizing them in three dimensions. For instance, if we were looking at the 4p orbital, here's what a p orbital looks like from the outside, but the radial part of the wave function for a 4p will have some structure inside where there's actually two radial nodes, and so inside it's going to look a little different. Combining these two together will give you a three-dimensional image that you can look, and the slicer allows you to look inside to see those structural details. So the functions are all here. Further down in the handout, we see an example of how to put this into MathCAD to generate the data. I'm going through here an example of a 2pz orbital so that you can see here the three pieces that we pull off the table, and then converting them to x, y, z coordinates involves making the substitutions for what r, theta, and phi equal. And now you can see the full-blown version of this formula here. Now, one thing to note about this is this is the fully normalized wave function. So if we were calculating probability, we would need to use this. But since we're simply visualizing the orbital as an image, we could scale it by whatever number we want. And so these constants that you see here could actually be ignored. There's no reason to keep them. In fact, by using the formula in its normalized form, the data numbers that go into Slicer will be very small numbers. And sometimes it's more convenient to work with larger numbers, and so you could replace these constants with 1,000 or 10,000 out in front. You'll have to experiment with that number a little bit. What do you want to scale this by such that the data for Slicer is not such tiny numbers? So for your report, you have to do, let's see where it says which orbitals here, 3s, 3p, and 3d. These are the required orbitals. For each of those, I want you to create a figure or several figures and make sure that you can see all the radial and angular nodes. And then also, in red here, I want to know the details about how you generated the image. So what's the color map, what ISO values, all of the choices you made in Slicer, the range, the grid, etc. Should be a part of your figure. You'll be just submitting figures, explaining them, and documenting them. If you want to go on and do some other orbitals, this is a little bit fun to do an f orbital or a different d orbital or even a 5g orbital. I encourage you to do that. That's all for extra credit. So let's get started with the lab. Have fun.